Rust on rebars. I got many comments on Instagram about rust on rebars. Does it do harm to the reinforcement? In this video I'm talking about rust on rebars, so keep watching. Now I'm talking about a topic that always leads to many discussions on Instagram, because when I post reinforcement pictures, they are always rusty. So this is not a normal tutorial video, but it's about a topic that always leads to many discussions and questions, and that's why I want to talk about it in this short video. I'm not a chemist, but I'm talking about the subject from the point of view of a structural engineer with the experience and with the education of a structural engineer. Structural steel is always protected by galvanization or by painting, by grounding. For any construction, the steel needs protection from corrosion. But in reinforced concrete, the concept is different. The steel is not protected usually. It's part of the game that the concrete in the end will be the protection for the reinforcement. As soon you have steel, unprotected steel, exposed to oxygen and humidity, you will have rust. And that's a question of a couple of hours or 2 or 3 days, and you will have rust. So the big question will be, is that a problem or is it not? And that's what I want to point out now. Maybe you live in a country with a dry climate with low humidity, then it maybe takes a week or 2 weeks, but in the end you will always have some rust on your steel. Now it's getting serious. The process of concrete hydration produces calcium hydroxide. I'm showing off a little. I'm not so much in chemistry. All we need to know is that the rebars inside the concrete are in an alkaline environment. The pH value of the concrete is between 12 and 13 or 13.5. So here's the good news. A sound concrete structure provides the perfect environment for a corrosion-less reinforcement. And it's even getting better, because the alkaline environment of the concrete will dissolve the existing light rust film that lies on the rebars. So even when you have some rust on rebars, when you uncover this after a couple of days or a couple of weeks, you will encounter blank rebars inside the concrete. That's an experiment you can do, you should do. That's amazing. And that's why I always tell people when they ask if it's a problem or why is there rust on the rebars, I always write the same thing. It's absolutely no problem having some rust on the rebars, because the concrete will solve this problem itself. Of course, when you have heavy rust, when you have rebars that have laid for a couple of months or even years around, and you have a reduction of section, then it's a problem, of course. So we are talking about light rust on the surface. So of course there are more topics we have to talk about concerning rust and corrosion protection in concrete, and that's the concrete cover. I've been talking about the sound concrete. That means no cracks, that means enough concrete cover, and that means a alkaline environment. And a concrete cover is so important because it makes sure that the reinforcement stays in this alkaline environment. So why is that so important? It's important because environmental impacts change the climate in the concrete from alkaline to acid. And once the reinforcement lies in an acid environment, the corrosion protection is gone. And what happens now is something sneaky, because now the reinforcement corrodes inside the concrete that looks from the outside looks apparently good and sound. And that's very sneaky, because you don't see anything, but the reinforcement will be corroding inside the concrete. And this happens because you have always oxygen, you have always humidity also inside the concrete. So what happens is that you have corrosion inside the concrete, and the corrosion grows big, and you have an expansion of volume, and then you have flaking off of the concrete. And that's the moment you realize you have the damage. And you have a big damage because you have the flaking off of the concrete, you have a corrosion, you have a large corrosion on the rebars, and you have a loss of section of the rebars as well. So what we have to do is to prevent the reinforcement from being in an acid environment. And how do we do this? We make sure that the concrete cover is big enough for the environment where your concrete is used. Of course, there's a lot of ways you can use concrete, but mainly you can tell 3 different ways to use to make it a little simpler. The first one is inside concrete, inside walls, inside slabs. Second one is outside for, let's say, normal use. And the third one is the de-icing salt environment, which is the most aggressive environment you can have for a concrete. Concrete covers you should observe for these 3 main uses are 20 millimeters for inside uses, 35 millimeters for outside uses, and 50 millimeters or even more, 60 or even more millimeters for de-icing salt environment. These are values we use in European countries or in Northern America, and of course you have to check your local codes for values you have to use in your country. And with these values you can make sure that the reinforcement will not be in a carbonated concrete environment, in an acid concrete environment, and the reinforcement will stay corrosion free. So this was a little trip in concrete technology. I hope you liked it. I hope you are a little smarter now, and I would appreciate when you hit the like button and please submit. I am working on a new video, a little longer video about the simple beam, which is an important topic, I think. So make sure you don't miss it. Hit the like button and submit. Thank you.